Hey everyone, my name is Alex Creely at Commonwealth Fusion Systems, and today I have the absolute pleasure of speaking with Gabriela Hearst. So, Gabby, when did you first learn about fusion?
I first learned about fusion reading an article in 2021, and my passion on sustainability and how to create and do business in a world that cares and put forward people and our planet, and realizing that we were looking at an energy issue, no pun intended, it's just fusion opened my mind to the possibility of a clean energy future, and it's made me hopeful, like very other things. So I wanted to spread the word as fast as I possibly can. But because you're the expert, why don't you tell people what fusion is and why I'm so excited about it?
Well, I'm excited too. I'm deep into fusion at this point. So fusion energy is what powers the stars. So most of the universe is running on fusion energy. And so what we're trying to do to build fusion is to basically build a star here on Earth and use it to make electricity. So we take hydrogen, a really abundant light gas, combine it together, form helium, which is not a greenhouse gas, it's non-toxic. You can suck it up and make your voice sound funny, put it into a balloon, and that releases a whole bunch of energy, which you can then use to power the world, to power anything you want to do.
And why it's so important for me to tell people about fusion is because we are moving our world in majority of fossil fuels. And the awareness that everything we are surrounding ourselves by, or we make, or we wear, or we eat, is produced with a certain energy. So it's clear that we need an energy as abundant as fusion, because if it created the universe and then it created us, I think it will be good to power the rest of the world. And I think it's another Prometheus.
The universe chose fusion to power most of itself, so it seems like a good choice for us to also use for something.
And what I'm also very attracted about fusion is the fact that if you go down the road and just a few years from now, in the near future, I'm excited because it can go into the grid and it can also leapfrog into developing nations. Because one of my biggest concerns are climate injustice and how people are living in the Horn of Africa right now. And the suffering that is going through a lot of parts of the world because of climate, and them that they did the least for how we live in the developed nations are paying the bigger price. So why wouldn't they are able to have hospitals or infrastructures? And so I think the idea of fusion being able to be available to many other countries that need it makes me very excited.
It's one of the big challenges of climate change in general, is that anyone anywhere in the world is causing part of the problem, but it affects everyone everywhere in the world, and in many cases the people that contributed the least to carbon emissions are the ones that are most affected by the effects by climate change.
That is exactly the unfairness, and to have them in our minds as we move forward, because the climate crisis and our path to climate success, how I like to refer it, needs to understand that we are all on this together. All the different conflicts that are happening today in the world, most of them are natural resource based. And so with abundant clean energy, we can also think of a peaceful future. We can imagine a lot of things, and it's been my devotion in the past years to really tell people about this, because good news don't sell.
And like spreading a message of hope is really important for something as big of a challenge as climate change. And on that point too, one of the big advantages of fusion is that it's almost like a manufactured energy. You don't need that many natural resources for it, so you're no longer fighting over these natural resources, and you no longer have to worry about who has them and who doesn't. You can produce this machine that goes into a location, brings all of its fuel with it. You need very little, and runs for years.
Very
producing
little
energy.
How
Very
much?
little.
Like how much? Like a glass or?
This would power probably all of my energy needs for my life. It's a lot of energy in a very small
I'll drink to
container.
fusion for that.
I'll drink to fusion for that too. Cheers.
That's why it's so exciting. And deuterium and tritium are abundant, and they're not as difficult to source.
Yeah, the type of fusion that we're working on at CFS and most companies around the world are working on, uses deuterium and tritium. Deuterium comes from water, so there's plenty of water on Earth. We only use a tiny little portion of it. And tritium you can make using lithium, but again, you only need a very, very small amount of it. And there's enough deuterium and lithium on Earth to power all of human civilization for thousands of years. So if we can figure out how to get this new energy source to work, we have the resources to do this. We can use this source for like a long time in the future.
I remember seeing the chart where exactly on that point where you could see how much we had been fueled by fossil fuels and by fusion, and it's really exciting. Again, good news that need to be spread. There are some challenges ahead.
There are challenges.
And what would you think, in your case, in what Commonwealth fusion system, what are the biggest challenges you have?
Yeah, it's a great question. So CFS has been around for about 6 years, and we're building on a type of technology called a Tokamak, which is the product of a lot of government research in the US and all around the world for the last maybe 60 years. And so in our case, we understand how these machines work fairly well. Like the physics is relatively well understood, and that's what I did my PhD in, is the physics of fusion. But integrating all this together into a full power plant is a really significant engineering challenge. So our technology is based on new magnets, where you can kind of hold your fuel and get it really hot without touching anything to cool off. And so this new magnet technology is a real game changer. And we've now demonstrated this technology, and some of the bigger challenges going forward are bringing this all together into a power plant. It's a lot of pieces, it's a lot of things that have to come together from all over the world, and then making it very, very, very reliable. So like we want to run these plants for many, many years continuously to power the lights, power the city, and doing that means getting all of this technology to work together reliably.
So just so people can visualize, a Tokamak has a donut shape.
It's a donut, yeah.
It has the ones you are building 12 magnets. 18 magnets, sorry.
Magnets, yeah.
18 magnets. And what you have been doing is trying to reduce, because if we look at ITER, for example, the intergovernmental biggest fusion experiment on development that is being in the south of France for over 15 years?
Oh yeah, 15 years now.
It's huge.
Yeah.
And what you have been trying to do it as technology gets better and evolve is compacting it and making it smaller and making it be able to commercialize.
Exactly.
So these D rings with the new magnets become lighter.
Yep. And smaller and easier to build. So I think the scientific research around the world has been really, really productive, but it has built science experiments. And so it's built these things that will help us understand fusion, but that aren't on a path to a power plant. So like, if we want to do fusion around the world, if we want to export it around the world, we want to bring it to these countries, it has to be affordable. This great energy source is not very useful if it is too expensive for anyone to afford. So our approach has been, we're going to do fusion in a way that is affordable to the world, in a way that people will adopt, the market will adopt, and that we can build everywhere. So this new magnet technology lets you take what would have been a huge, very expensive machine, and make it much smaller, and that way we can build it wherever we need to. Unfortunately, it won't fit in your car yet.
No.
We're not there yet, but
you can plug your car.
Yeah, you can plug your car into it. You can power New York City.
You can power New York City. This is what I find that the excitement as well is that there is, since I started researching it till we did a show about it, you came, and it has been so much evolving. At the beginning, when I started talking about fusion, people would look at me, because outside of the community, we would be like, what are you talking about, fusion food? And now there's more and more in the news, in the common public. And we're just in Dubai with Secretary Kerry doing the first international fusion plan and strategy. And it's really exciting that it's becoming more, this is never going to happen, to a reality with obstacles to overcome. But for me, and it's the fact that people need to know so they don't feel so debilitating about the magnitude of what the climate crisis is. That to not just drink the last tequila at the bar and let the house go on fire, because there are solutions coming. And as we usually say, good news are harder to sell. But I get so hopeful when spending time with you, when I see the journey in the past 3 years of how much more development there are. For example, just in Tokamak, how many Tokamaks around the world?
More than 100. More than 100. So people are working on these all around the world. And I think, to your point, this is new. It's something new. And we want people to be excited about it and hopeful about it, and not scared or not just so, giving up on the ability to do something about climate change. So maybe when you first learned about fusion and were getting more and more interested, like, where did you see that interest going? What did you see as like that partnership turning into? I
truly found my holy grail from somebody that had been in this journey from the materials that we use in our collection. I refused to use cotton till we were able to use recycled cotton because of what it does to our environment and biodiversity and water consumption. There's this false statement that the fashion industry is the second biggest polluter. That came out of our conference and news, big titles, but it's not true. What we are not really good at is at water wastage. We waste a lot of water, and one part of it is cotton. So I've used linen. I've done all these different materials. A lot of it has to do with using merino and wool. So a lot of my efforts went into materials. Then we changed all packaging in 2018 to biodegradable and compostable packaging in our industry. We were one of the first to do a measure the carbon footprint. We spent a whole strategy on retail where we don't use window displays, no mannequins. You've been to our stores. It's still a luxury experience. And
displays the clothing, but it
displays the clothing without wastage.
Without waste,
So being very smart about cutting the extra, right? Being what is the message, what we don't need. Being careful with our natural resources, to actually moving the needle and being one of the first to actually digital ID, to doing other transformative exercises. But realizing when I saw fusion, this was it for me, because it just was obvious that we were talking about sustainability as an energy situation, and the reality we're in is because we are here because of the Industrial Revolution and because of the usage of fossil fuels and how we rely on them today. And so I feel that I invited myself to this party because
We're glad to have you.
Thank you. Because I'm not a politician, I am not a scientist or a physicist or an investor. So I can transparently say, I'm here to talk about this, inform myself, tell as many people as can hear me, because I have zero interest besides the fact that I believe it will save our butts. And so I think you have to have that position when we talk about transparency and honesty, where there's no other agenda than this is really cool. We need to be hopeful here and spread the world. And I'm also very excited of what we were talking earlier about, that there is advancements.
I think the statement of as soon as the technology works, we need to put it everywhere as fast as we can to really attack. We don't have the time. As a company, it's interesting because we don't see ourselves as competing against other companies. Like, we are competing against the clock of climate change is happening. It's happening all around the world. It's happening quickly, and we need to go quickly so that we can have an impact. And then the longer we wait, the less impact that we have.
Yes, and we already, a lot of scientists are saying that we already reached 1.5 because of measures that they've done in the ocean. And scientists have been very accurate overall predicting what they already knew for the 50 years since the first Earth Day. But what there has been a miscalculation was how much heat our oceans have absorbed for us. And so in simpler words, the oceans have been subsidizing our global economy. So we're on borrowed time. So we really have run out of time, and the oceans have given us a bit more
than we thought we might have.
So you need to hurry up.
We're working on it. I'll get back to it.
But talking about hurrying up and speed, one of the things that I really liked about CFS approach was you were doing both, the demo and the commercialization.
Yeah, so one of our strategies is that we need to develop this technology, but we also at the same time need to get ready to deploy it. So we've developed this magnet technology. In parallel to that, already we were designing our first demonstration plant that we call Spark. We're now building that demonstration plant. And in parallel to that, we're getting ready for our first power plant, our first commercial plant we call ARC. And all of that's happening together, and all of that is happening at the same time as talking to people that might eventually purchase this, talking to the communities where it might go, talking to governments that might be involved with it. So we don't want to get ahead of ourselves. Like we need to have the technology ready to deploy, but at the same time, once it's ready, we need to have all of these other pieces in place so that we can go quickly and do everything in parallel. So yeah, an important piece of the organization.
And how did you get interested in fusion?
Yeah, great question. Growing up, I loved the outdoors. I go hiking all the time. I was in the Scouts. I really enjoyed that experience, and it was like an important part of me growing up. And the more I learned about the climate change, the more I was worried that future people won't have that experience. Like they won't be able to go and experience the same outdoors, the same nature that I was, or that I had. So I was very interested in working somewhere in clean energy. Didn't entirely know what yet. I liked building stuff, so I was going to mechanical engineering. And by chance, I saw a poster one day advertising a tour of a fusion lab. I'm like, wow, that sounds really cool. Like I've never heard of this before, so I started reading about it, went on this tour, and the more I learned about it, maybe similar to you, the more I was like, we have to try this. Like this is so important. It's such a big challenge, and this is such a important step that we can take towards solving it. So I did some internships in fusion, decided to go to grad school to learn more and more about the topic and get more involved. Did a whole a whole PhD in it. And then as I was finishing up, I learned about Commonwealth fusion systems. It came out of the same lab that I was in, so I knew a lot of people who started
at MIT?
At MIT, yeah. So the same lab I was at MIT, this company came out of, and at the time, again, going back to speed, it's like there were a lot of government programs which were doing great research, contributing to all this, but moving deliberately. And then there were these startups that were coming to the game and saying, the research is great, but we have to go faster.
Yeah.
And for me, the science is interesting, but I'm here for the climate story, and I'm here for being part of the energy transition. So the speed was really important for me. So I came to CFS, and I've been there 5 years now. So it's been a while.
I am so grateful for the synchronicity in life that made you look at that
I'm glad
poster.
I saw that poster. Yeah.
Exactly, and we're all gonna benefit for it, I'm sure. And fusion facility, both private and public, and I find the integrity of Commonwealth fusion system and the transparency something that is very rewarding, and you're publishing your papers regularly.
Yeah, we think that being open about the work we're doing is very important. So we publish scientific journal articles in peer-reviewed journals, so other scientists from around the world review our work to say that, yes, they agree with the conclusions. And we also think it's really important to do this open access, so there's no paywall. So anyone that wants to can go download these scientific journal articles, review our work. If you see something that you're like, oh, that doesn't seem right, you can tell us. My email's on there. You can tell us, and we want to continue doing that. So this is our, speaking of being getting people excited, we want to be very open with the physics, and we want to contribute that to the broader society's understanding of fusion. So I know you've mentioned transparency, and Gabriela Hearst has also been an important kind of piece of building trust.
I think open source has been the key thing is collaboration. We can look at different points in history and problems that we've had as a society, and we know that collaborating and transparency through all parties it is just the way forward. So anything we use or do, I was always open to share. Whatever, as you say, and also being challenged if there's a better option for that. So it is the climate story because I love what I do. I mean, I grew up in a ranch. My mother, we are 7th generation ranchers, and nothing affects you more as seeing climate change change the place where you are. And my mother's ranch is actually regenerative agriculture because they still maintain the same pre-industrialization practices. But I grew up in a culture of small amounts, well-built things that last, right? Of not opposite of overspending or overconsumption. It was really, and everything has to be circular. Like we would make our own soap, everything. You're 2 hours and a half from the closest city. So that for me is my formative years, and my neural pathways were created in this way of understanding that, as you say, it's not knowing if my children can see the same landscape that my family has seen for 7 generations. It's the challenge.
Do you think that sustainability is like a core responsibility of the fashion industry? Like, is that like a core piece of what should be part of the business?
I think every industry. I think about it in every single scale, because the responsibility of the food industry is like who has greater responsibilities. It is all about the excess. And a lot of these things are not done with ill intentions. This is what people don't really, nobody's doing something. It's practicality that sometimes and comfort that sometimes take us to the wrong places. Point example, like styrofoam.
It's easy.
It's easy, but styrofoam is going to be existing in our planet long after we're not here. Like I want to eliminate styrofoam from this existence we have. It's not. But also, how do we end up with polyester in our clothes? Very recently now, people are understanding that what happened with the microplastics and what's getting into. We don't pay attention to what we're putting in our largest organ, which is our skin.
The skin,
But we started to use polyester after the Second World War in Italy because of the restrictions. The materials that they could get is polyester, and Italians being very creative, they started to do all this.
They figured out how to use it.
And it changed everything. It changed the way, right now if you look, talking about merino being one of the most sustainable fibers you can use, wool is like 2% of all fibers that's used. And 2%, most of it being cotton and polyester. And if you think go back, I like to go in fashion, I like to go back in history. In energy and technology, we go to the future. But in fashion, in Roman times, I always give this example. We were dressed in linen, leather, and wool. And so going back to those natural fibers that are resilient for centuries or millennia, I think it's worth keeping because it worked.
It works,
It worked. So again, it's a lot of the things that we do and have become part of our daily life or habit is not from ill intentions. It's just because it was easy.
And much of that's true of energy as well. It's like people use fossil fuels not because they're intentionally trying to make climate change happen, but they're easy. Like they're around. They're efficient for carrying energy in your car places. But if you want to get away from that, you have to be very intentional about it. You have to, and in the same way as choosing different materials intentionally, you have to be very thoughtful about, okay, well, I know this is easy, but it has these larger effects. In order to get away from those larger effects, you need to be very intentional. You need to think about, how is my choice here affecting a much larger picture, and move to other ways of energy. So move to wind and solar, geothermal, these other sustainable things, and hopefully soon, fusion energy.
My country's all hydro. So because we never grew up, we don't have fossil fuels in Uruguay, and thank God, because that giving us some stability to the country.
Yeah.
So I understand that you can live very well with other sort of energy, but I think that I'm a visual person.
Yeah.
And I look at fossil fuels and I look at fusion, and harvesting the energy of the sun looks visually more appealing to me than extracting dead dead things from another geological time.
Yeah.
Taking it out from the earth, burning it, and shooting it out to the sky. I definitely like the visualization of fusion much more, and plasma, which is, I was looking for examples of what plasma is, and again, much more beautiful. The aurora borealis.
The aurora borealis, yeah. Yeah, so maybe like backing up. So plasma is a state of matter. And normally you think about 3 states of matter: solid, liquid, gas. It turns out if you take a gas and you heat it up even hotter, the electrons separate from the nucleus of the atom, and you separately have these nuclei and electrons kind of flying around. So some people call it like an ionized gas, but that's a plasma. And yeah, the aurora borealis is a plasma. Neon signs actually have a little bit of neon plasma in them. Stars are all plasma. Lightning's a plasma. So there's more plasma around us than most people might think.
So again, a much beautiful idea. And also, I don't know why the Tokamak. I built a runway with a Tokamak. But
you had the magnets around it too. You were ready.
And exactly,
ready to do fusion.
Ready to do fusion. But the circular, from a visualization, from a creative perspective, the circle, the visual of a circle of that shape, it seems so prehistoric. Like if you look at Bronze Age, and if you look at Stone Age, even these shapes were there.
Yeah. Yeah.
These shapes in our conscious were there, so there's something very artistic.
And it's interesting that like the Tokamak shape, it's form and function come together on that one, and that it's that shape very much for a reason, because the plasma will kind of move around in the circle. It'll mix itself around that way, and there's no like ends for it to leak out. And so that our donut, the circle shape allows you to have no ends of it. Similar to like maybe how other people in the past thought about circles having no ends, and a sustainable economy should have no ends. Like things will go circular. So it all comes back together somehow.
And it's the renewal.
Yeah.
And so just on how let's visualize that we have our device reactor. What do we want to call it? Power plant. And so, what are can we switch it off, switch it on?
Yeah, so one of the big advantages of fusion, or a couple, one of the big advantages is that you can turn it on and off when you need it. So like wind and solar power are great. We should build more of those. But the sun's not always shining, the wind's not always blowing, especially depending on where you live in the world. Some are better or worse locations to do it. So fusion, you can turn it on when you want, you can turn it off when you want, you can leave it on for a very long period of time. And so you dispatch it when people are waking up in the morning and like making their coffee. They need some more electricity. You can make sure your fusion's running at that point to get things ready. I think one of the other big advantages is that it doesn't take up much space. So wind and solar are great if you have a lot of land.
Yes.
Hydro is great if you have a lot of rivers.
Yes.
If you live in a major city, if you live in New York City, there's a lot of energy usage in a very small amount of space. And so fusion's great for that, because you can build small power plants that don't take up very much land, but make a lot of power. So we actually think a little bit that fusion is a piece of a larger like energy ecosystem. Like we don't think everyone's going to use fusion. Hydro is great, solar is great, wind is great, geothermal is great, but there are certain situations, like big population centers or areas where you don't get much wind or not as much sun or don't have large rivers, where fusion is like a really important piece of that transition to clean energy.
I can't wait, and it's my biggest dream and my biggest wish in every birthday that I'm able to see fusion come as a reality in the very near future.
Yeah, I mean it's again we're in a race against the clock, so it's something we have to do quickly. Gabby, it was great talking with you, as always. It's always good to see you, and I'm so glad that you learned about fusion and that you've decided to kind of get involved in this whole effort to make clean energy.
Always great talking to you, and I am so glad that you're actually doing it because it gives hope for all of us. Thank you so much.